In this video, we are going to discuss about how to implement Stagger tuned amplifier using multisim. The perfect one, we go to the multisim, go to place component. So first I'm going to select the resistor value. Okay, so I require nearly, so instead of that, I'm rotating this one and I'm going to copy and paste. Okay. So I'm just copying it and pasting it. Like this also you can do. Okay, so next I'm going to select the capacitor. So the explanation of this circuit, so I will give it to you in the description box, or I will mention it in I icon. Next, AC voltage. I'm going to select AC voltage. Then I'm giving the connections. Okay. So here I'm going to use two-stage single tuned amplifier. Okay. So you know the circuit diagram of the single tuned amplifier. So I'm just starting like that. So next I require a ground. So I selected this one. Okay. So I'm just changing the values of the capacitor as 0.587 microfarad and resistor as 52.5K and R2 resistor as 75 kilo and the resistance as 6 kilo, that is R3. So I'm going to change the input voltage as 35, mainly peak to peak voltage, and frequency as 450 kilohertz. Next I require a DC supply and also I require a transistor, right? So you go to all source, right? All group, or you go to transistor, then you select 2 and 4 doors. It is nothing but a NPN BJT transistor. So you connect it like this. Okay. And you rotate. I also require one capacitor and inductor. So for that one, so first I change this capacitor. Just copy this capacitor, rotating 90-degree clockwise, and I also require a inductor. Okay. So L and C are connected in parallel. So that is nothing but a tuned amplifier. So the tuned circuit is connected at the connected terminal of the transistor. So that is called as tuned circuit, and the tuned circuit which is connected in the connector of the transistor is called as a tuned amplifier. Okay. So this is called a single tuned amplifier. Okay. So just copy this one and I'm going to place it here. Okay. and you can see I don't require this capacitor and input voltage source, so I just connected like this. Okay, and I want to change the tuned capacitor, tuned circuit values, that is L2 and C2. So first I will fix the value of L1 as 132.3 nanohenry, and here I'm going to fix it as that is for L2 I'm going to fix it as 50 nano Henry, and C5 value as 100 microfarad. Okay, so I need a DC supply. So for this one, just can connect either two DC source, or I can use one DC source, that is enough. So just connected this ECC, and as it change the voltage as 12 volt for both ECC. Then I need to connect okay, so I have to use the body part. Okay, so just selected. So one is input and another one is output. First the minus pin is connected to ground. Okay, so the input is connected to V1 terminal, and the output is connected to the cut of the second transistor. So I'm going to save this project, right? So I can have to correct the bypass capacitors. Okay, so just rotate this one. So and I connected like this. Okay, so you have to have a red line. So in order to get the red line, I have to bring this resistor some well. You have to select the resistor. Now I can connect. Okay. So just save this project, giving the name as Stagger tuned amplifiers. Save the project. Then I'm running this song. So if you see, I have the output like this. So here both the so this is the output of the Stagger tune amplifier. So this represent 1 divided by 2 pi of root of L1 C3, and another one represent 1 divided by 2 pi of L2 C5. Okay, so these 2 points. Okay, so if you see the applications of this Stagger tune amplifiers, it is used in a super heterodyne receiver as an intermediate frequency amplifier, and it is used in the ultra high frequency radio relay systems, and it is extremely narrowband intermediate frequency amplifier within a spectrum analyzer. It is used like a wideband tuned amplifier intended for Y amplifiers within oscilloscopes. IF amplifier in a satellite transponder. It is also used for video applications like wideband tuned amplifier. So, if you see the advantage of this amplifier is the bandwidth is root 2 times single tune amplifier, and this amplifier has high value of gain bandwidth. So, if you see in every stage of this amplifier, there is a small difference within the resonance. Therefore, it enhances stability within the operation. And the band pass of this amplifier is faster when compared with the single tune amplifier. So, therefore, the alignment of this circuit is easier when we compare it with the single tune amplifier. So, from the above information, finally, we can conclude that this amplifier are usually designed so that the total frequency response exhibits the maximum flatness, approximately the middle frequency. It requires several tuned circuits to operate in combinations. Once the frequency is changed above and below, the resonance frequency will fall off quickly. So that is what we see in the output. So I hope this video is useful for you. Thank you.